Welcome to Geometry 6.6. In 6.5, we talked about inequalities just in one triangle. Now we'll talk about inequalities in two triangles for 6.6, starting off with what's known as the hinge theorem. So here's what the hinge theorem states, and I know this only represents one triangle, but if you have two sides of one triangle, just pretend I had this is a board compass here, but if I have two sides in one triangle that are congruent to two sides in a second triangle, and if the angle of the first triangle is larger than the angle of the second triangle, then the third side of the first triangle, if you're keeping track of everything here, is longer than the third side of the second triangle. Or another way to state it is just taking a look at this hinge, a simple machine right here. As I open up the angle between these two sides, the third side gets longer. As I close the angle or make the angle smaller, then the third side gets shorter. That's basically what the hinge theorem states, except you're taking a look at two triangles. So I have the hinge theorem written out in words, and then I'll go through an illustration of the hinge theorem. So here's my triangle. If two sides of this triangle are congruent to two sides of a second triangle, so here's triangle ABC, even though I haven't made the full triangle yet, and then triangle DEF. But side AB is congruent to side DE, side AC is congruent to side DF. Let me put in specific angle measures here. Let's just say the measure of angle A or BAC is 50 degrees. The measure of angle D or EDF is 30 degrees. So this angle, angle A, is definitely larger than the 30-degree angle. That's the included angle between the two sides. Then side BC has to be longer than side EF. That's what the hinge theorem states. Since the measure of angle A is greater than the measure of angle D, then side length BC has to be greater than side length EF. Before we go over the converse of the hinge theorem, you know what a converse is. If you didn't notice, the hinge theorem is actually written as a conditional statement, so you could take the converse of that. But here's what the converse of the hinge theorem states. If you have two sides of one triangle congruent to two sides of a second triangle, and the third side of the first triangle is longer than the third side of the second triangle, then the included angle between the congruent sides of the first triangle is greater than the included angle of the two congruent sides of the second triangle. That's the converse of the hinge theorem. So there's the converse of the hinge theorem in words. I didn't label anything in these two triangles, but I have triangle ABC, and maybe you're thinking for my triangles, it looks like they may be congruent. So kind of trust the given information as opposed to the diagrams here. But I have triangle DEF. And here's what I said. Two sides of triangle ABC are congruent to two sides of triangle DEF. If I know that side BC is longer than side EF, I'm just writing that as an inequality, then the conclusion that you can make is that angle A, the measure of angle A, is greater than the measure of angle D. That's the converse of the hinge theorem.